Welcome to the video related to creating a large network topology using Mimic Simulator. Network discovery is an essential component to any NMS and is utilized to ensure the health and availability of your network. With Mimic Simulator, you can design and create a simulated network topology to be used to test every aspect of your network discovery tool. In this video, you will see how you can create a large simulated network using Mimic Simulator's network topology package and discover those devices using a network management application. We will show you the steps to do that. The topology package lets you create a small network or scale up to a large network with thousands of connected simulated devices. Let's begin and create a network topology. The first step is to start the Mimic Simulator, as indicated here with the display of the Mimic View graphical user interface running on a Windows 7 platform. Next, download the Mimic topology package. This is a sample package containing specific simulated devices, a configuration file with connection definitions, and scripts. The configuration file contains the information about the size of the topology you want to create. You can modify to increase or decrease the size. With the package downloaded, we need to copy it into the Mimic private area. The private area of your system will be displayed in the title bar area on the top of the Mimic View graphical user interface. For this system, the private area is defined as C:apps my Mimic. Let's extract the package. Looking at the extractions, you can see the configuration directory. Any changes that you make to the network can be saved to this file location. For instance, to save the network in Mimic View, go to the menu bar, select File, and then the Save option. Next, you can see the data directory. This is where the specific simulation files reside. These are the device simulations that will be running in Mimic and discovered by your discovery tool. Finally, we have the scripts directory, which contains all of the necessary supporting topology-related scripts that will be executed to create the network topology. In addition, here is the topology configuration file mytopo.cfg we talked about earlier. This file defines the connection information for each of the simulated devices. In other words, the network topology is defined and controlled by the information within this configuration file and the information stored in the Mimic value space for various MIB objects and tables. Let's open this file using the Mimic IDE. Observe the connection blocks that are defined. They are denoted by the CONN tag and represent a single connection. Let's look at the first block. It specifies a device simulation pair via agent ID numbers. For this connection block, we have agent ID 1 and agent ID 2. You can also see the simulation types associated with each of the agents. In addition, the highlighted information also defines the connections between device simulation 1 at interface index 2 with IP address 192.168.0.1 and device agent number 2 at interface index 2 with IP address 192.168.0.2, both with a net mask of 255.255.255.0. Scrolling through this file, you can see we have a number of connection blocks. This file defines connections between 25 simulated device instances and can easily be modified to scale to thousands. If you need a larger network, just copy more blocks into this configuration file. Other files included in this directory are the sample topology image, which shows the topology you can expect on your NMS after it connects with Mimic, and a README file which provides detailed information regarding this package. Okay, we are now situated to start the process of creating a network topology. We begin by clearing the canvas area for a fresh start. To do this, go to the Mimic View menu, then select File, then New. Click OK, and observe the cleared canvas area. The next step is to run the settopo.mtcl script to begin the process of creating the network topology. We will do this by sourcing the script from Mimic Shell. Hit Enter to begin execution of the settopo.mtcl script. You can see the script actions here. Agents are being added to Mimic View. Next, you can see the script is starting each of the devices and configuring them. When the script is done, simply press Enter to exit Mimic Shell. Observe all of the added agents are running, as indicated by the green icons, and are ready to be discovered by our NMS discovery tool. I will use a third-party NMS tool, SNMP by Castle Rock. Let's now launch SNMP Network Manager. From the SNMP Management Console, let's define a subnet seed value for discovery. Here is the net mask that we will use, as defined within the mytopo.cfg file. Let's begin the discovery by going to File and then clicking on Reset. With the map view open, observe all of the discovered simulated devices currently running in Mimic, along with the connections that were configured. You can do the same thing using your NMS by pointing it to Mimic to see the same topology. By looking beneath the root subnet branch located on the left panel of the map view, you can see the 25 discovered device instances. I mentioned earlier you can scale up to thousands, and you can see that here from an image illustrating Avaya's VPFM application showing the discovery of thousands of simulated devices that were running in Mimic, and this started with the same topology. Again, all you have to do is change the mytopo.cfg configuration file based on the size of the network you need, and then run the script. I hope this video provided you with some insight on creating a network topology in Mimic to test and verify the discovery tool of your NMS. Thanks for watching.